Hi sir, good evening. Myself Veera. So today my topic was hydraulic turbines. So we are going to see today what are the types of turbines is there. So according to the turbines, radial type of functions, we need to see what are the types of functions and all turbines. So what is turbine? Turbine is a defined as hydraulic machine which convert hydraulic energy into mechanical energy. So normally turbines are used in running the electric generator which is directly coupled to the shaft and the turbines. Just the mechanical energy is converted into electrical energy. Classification of hydraulic turbines. So there is several classification is there. So according to the type of energy at inlet, impulse turbines, reactant turbines. So it is the classic type of energy. According to the direction flow of tangential flow turbines, axial flow turbines, radial flow turbines, mixed flow turbines. First we are going to see the impulse turbines. So impulse turbines, nothing, it is a water from penstock turbine via one or more nozzle. Okay, that is a impulse turbine. Pressure energy converted into kinetic energy. The basic principle of impulse turbine is pressure energy converting into kinetic energy. This is a rotation of the wheel due to tangential force created by impact of jet. That is the impact of the impulse turbines. Second one is reaction turbine. Reaction turbine, nothing but both kinetic and pressure energy is kinetic, feeding the water through the fixed blades in casings. So static pressure at the inlet is greater than the outlet runner. In the reaction turbines, rotation due to the impulse reactions and due to reduction of pressure, so it is called reduction turbines. Reduction turbines. So according to the water head and the quantity of water available, we have three types of head. Head is small water, medium head, medium flow rate, low head flow rate. According to the specific speed of the turbines are classification: low specific speed turbines, medium specific speed turbines, and high specific speed turbines. So first, low specific speed turbines are Pelton wheel. So Pelton wheel is normally used for low specific speed turbines. It is a less than 60 Newton per speed meter. Medium specific speed turbines is example what Francis turbines. It is a range of 60 to 400 Newton per seconds. High specific speed turbines is above 400. It is normally ship interval is using. Okay. Another one is impulse turbines. At the inlet of the turbine, energy available in the outlet of the kinetic energy. So normally seeing more in energy. Then we are going to see difference between impulse turbine, reaction turbine. Impulse turbine, all the potential energy is converted into kinetic energy by nozzle before entering the turbine runner. Reaction turbine, only portion of the fluid energy is transferred into kinetic energy before the fluid enters the turbine. So major difference, the kinetic energy nozzle before entering the turbine runner, but in reaction turbine in transferred the fluid energy before the turbine it starts. So flow regulation is possible without losses. Flow regulation is possible with losses only in reaction turbines. In impulse turbine, unit is installed above the tail race. In reaction turbines, the unit is kept entirely submerged in water below tail race. In impulse turbines, blades are only the action when they are in front of the nozzle. But reaction turbines, blades are in action at all the time. That is the difference, major difference. So another one of the major turbines are Francis turbines. So Francis turbines, they are used in normally ship. There are components is there: water supply, turbine, wicket gate, and water jacket and all. So normally in motors and all they are using. So turbines is Francis turbines. First of all, designed we need to say manufactured, designed and developed by American engineer James V. Francis in 1848. Head engineer, textile factory, Lower Mashless, improved this design turbines 90% efficiency. So water in Francis turbines, normally water head is 10 to 650 meters. Power output range is 10 millivolt to 750 millivolt. So speed range is 83 to 1000 rpm. So main components of the turbines are spiral casing, guide vanes, runners, governing mechanism, and draft tube. The most common turbine type is hydroelectric stations. So hydroelectric station. So again, the main components of Francis components are governing ring, special casing, guide vanes, upper cover, stay vanes, runner, draft tape cone, lower covers. These are the components available in Francis turbines. So in the components, what are the functions they are doing? We need to explain. So penstocks, large diameter tube through water dam comes turbine inlet. It is made from steel. Spiral casing, it is a closed passage whose diameter gradually decreases along flow direction. Area is maximum, inlet nearly zero at the gates. So made of cast steel, concrete depends on head. Guide vanes, it is a aerofoil shaped vanes fixed between the two rings. It is a convert the body pressure energy into kinetic energy. Each guide vane rotates about the center ends, also serves to direct the flow direction angle between the runners. Another one is governing mechanism. It can be changed the position of the guide vanes to vary the flow of the turbine. So runner is a very important component in turbines. Profile is designed so that water enters in the radial direction and leaves in the axial direction. It is classification according to the medium and slow. It is keyed to shaft turbine. So final one is draft tube. It is a gradually expanding tube which discharges water positioning through the runner to tail race, generally with increasing diameter in flow direction. So in Francis turbines, there are low speed and high speed. There are two types there. So another one is very important is Pelton turbine. Pelton turbine, already beginning I have told that it is a impulse turbines. Okay, the Pelton wheel is a water tangential flow impulse turbine. So that Pelton turbine, it was invented by Lester Allen Pelton, an American engineer in 1870s. So all the turbines are designed by only Americans, not Indians. So this turbine is used for high heads. The main components of Pelton wheels are turbine. There are several components in turbines. In Pelton turbines, nozzle and spear, runner and bucket, casing, braking jet. So Pelton wheel is connected with the cups and buckets, and the double hemispherical buckets are connected with the nozzle. The spear valve is needle valve, water inlet. Both are connected with the Pelton wheel. It's combined to the attached to the Pelton one bolt. So what are the components they are doing? Functions we need to explain now. So nozzle and spear. What is the function of nozzle and spear? Amount of water sticky the bucket of the water controlled by spear in the nozzle. Spear is conical needle which operated either by hand, wheel, over, automatically, axially, depends on the size of the unit. Runner is very important component in the Pelton wheel turbines. It consists of circular disc or periphery of which number buckets spaced or fixed. Shape of bucket of double hemispherical copper. Each bucket is by splitter which is divided to jet into two parts, made of cast iron or cast bronze or stainless steel, depends on the head. And casing is nothing but the prevent splashing for water. So casing is nothing but normally this prevents from the splashing with water, act as a safeguard. Made of the casing is made by cast iron, fabricated steel. And the final one is braking jet of the water used to stop runner in short time. It strikes at the back of the van. So normally the braking jet will be involves water to use to stop runner, and it will be normal to time. So now we completed the turbines. So now we already go through all the turbines, what are the classification, radial turbines, impulse turbines, Kaplan turbines, all. So hope you are enjoyed more. Thank you sir.